All right, from the previous section, we obtained the following general results. Remember, previously um, we differentiated by first principle, or by using the definition. We differentiate f of x is equal to c, and we got 0. When we differentiated x using first principle, we got 1. When we differentiate x squared, we got 2x. And the derivative of x cubed is 3x squared. And the derivative of the root of x, which is x to the half power, is 1 over 2 root x, which is the same as saying a half x to the minus 2. If we look carefully at these results, we could obtain a general rule. All right, and essentially, what the general rule is saying, as indicated here, what the general rule is saying is that if f of x is some function of this form where x is raised to some power n, when you differentiate f of x, the power n comes to the front and the power of x decreases by 1. All right, so that's a general rule for the first principle derivative that we did in the previous video. So, for example, let us use this rule to deal with this question. Here we have f of x is equal to x to the fifth power, and we're to find um, the first derivative of x, or we're to find f prime of x. F prime of x is the first derivative. So remember, the power comes to the front, so we have 5x, and the power decreases by 1. So it moves from 5 to 4. That's simple that. All right, from the rule, if you have a function of the form f of x is equal to x to the n, when you differentiate it, the power comes to the front and the power decreases by what? 1. All right, let's have a look at a few more examples. In example 7, we're told that f of x is equal to x to the 4 over 7. Now, f prime of x, which is the first derivative, the power comes to the front, so we have 4 over 7x to the 4 over 7, and the power decreases by 1, you minus 1. So f prime of x is 4 over 7x to the minus 3 over 7. All right, if the signs are different, subtract and keep the sign of the larger number. All right, example 8. In example 8, f of x is equal to 1 over the root of x. The root of x is the same as saying x to the half power. So this is the same as saying x to the minus a half power. All right, and that is using our laws of indices. Now, f prime of x, when you differentiate a function of this form, the power comes to the front. So we have minus a half x to the minus a half minus 1. Now, minus a half minus 1 is minus 3 over 2, or minus 1.5. So this is minus a half x to the minus 3 over 2. All right. All right. Differentiation of a g of x, where a is a constant. If f of x is equal to a gx, f prime of x is equal to a g prime of x. In other words, the first derivative is, say, if you have what? A number multiplied by a function. When you differentiate if a function is some number multiplied by some function of x, when you differentiate that function, you keep the number and you differentiate the function of x. So in other words, if y is equal to a g of x, dy by dx, which is the first derivative, is equal to a times the first derivative of g of x. Essentially, that is what it is saying. So let's have a look at an example. All right, example 10. In example 10, we're told that f of x is equal to 4x. Now, f prime of x is going to be 4 times the differential of what? X, but the differential of x is 1. So it's 4 times 1, which is 4. All right, so f of x is equal to 4x is in the form f of x is equal to a g of x. All right, where g of x is some function of x. When you differentiate it, you keep the constant, which is the 4, multiplied by the differential of the function of x. Differential of x is 1, so it's 4 times 1, which is 4. All right, example 11, f of x is equal to 6x to the third power. Again, this is in the form a g of x. When I differentiate f prime of x, it's going to be 6 multiplied by the differential of x cubed. The differential of x cubed is the power comes to the front, and the power of x decreases by 1, so it's squared. So therefore, f prime of x is equal to 18x squared. All right. So in example 12, we have f of x is equal to minus 4 over x to the fifth power, which is the same as saying minus 4x to the minus 5. That's using our laws of indices. All right, so that's f of x. Now, f prime of x is minus 4 times the differential of x to the minus 5, which is times minus 5, the power comes to the front, x to the minus 6, the power decreases by 1, and minus 5 minus 1 is minus 6. So therefore, f prime of x would be equal to, a negative times a negative is a positive, 20x to the minus 6. All right, we can bring back the x down. So this is equal to 20 over x to the power 6. All right, so differentiation of sum and difference. All that this is saying is that if you have a function f of x, which is equal to, all right, this probably shouldn't be an and here. What should be here is a plus. So let's see if we can remove this safely. So if we have a function f of x, which is equal to a function g of x plus some other function m of x, f prime of x is the derivative of g of x plus the derivative of what? M of x. All right. So let us show you what that means. Example 14. In example 14, y is equal to 4x squared. So that could be like our g of x plus 3x, and that could be like our m of x. Now, when we differentiate, it is simply the differential of the first one plus the differential of the second one. So dy by dx, which is the first derivative, is equal to 4 times 2x, the power decreases by 1. 2 minus 1 is 1, plus 3 times the differential of x, which is 1. So therefore, dy by dx is equal to 8x plus 3. Example 15. In example 15, y is equal to the root of x plus 1 over x. So this is the same as saying y is equal to x to the half power plus x to the minus 1. Now let's differentiate dy by dx. So the power comes to the front, so it's a half x, and the power of x decreases by 1. Now a half minus 1 is minus a half, so this is minus a half. Now here, the power comes to the front, so let's say if we want, let's spell it out. Minus 1 comes to the front, so it's minus 1 times x, and the power decreases by 1. So minus 1 is minus 2. So dy by dx would be equal to a half x to the minus a half minus, because a positive times a negative is a negative, x to the minus 2. And if we want, we could say dy by dx is equal to 1 over 2x to the half minus 1 over x squared. So dy by dx would be equal to 1 over 2 times the root of x minus 1 over x squared. All right, example 16. All right, example 16, we have A says A says y is equal to 6x to the fifth power plus 4x cubed plus 3 over x squared. So we can write that y is equal to 6x cubed plus 4, sorry, it's not cube, it's to the fifth power, to the fifth power plus 4x cubed plus 3x to the minus 2. All right, so the power is at the bottom and you bring it up to the top, it changes the sign. All right, and that is from indices. Let's differentiate dy by dx. So by now you should see that the power at the top, you're going to use it to multiply by the number at the front. So it's going to be 6 times 5x, and the power decreases by 1. The power becomes 4. Plus 4 times 3, the power comes to the front, to multiply by that number at the front. X, and the power decreases by 1 from 3 to 2. Then we have plus 3 times minus 2x to the minus 3. So therefore, dy by dx would be equal to 30x to the 4 plus 12x squared minus 6x to the minus 3. Then I could further write it as like this. This is 30x to the 4 plus 12 x squared minus 6 over x cubed. All right, let's have a go at b. All right, so b here, this is y is equal to x squared plus x to the minus 4. Power at the bottom, positive at the bottom. When you bring it up, it becomes negative. Minus 2x to the power half. So square root is the same as saying that the power is a half. So dy by dx, which is the first derivative, the 2 comes to the front, x and the power decreases by 1. The minus 4 comes to the front, x and the power decreases by 1, that's minus 5. So minus 4 minus 1 is minus 5. This is minus 2 times a half, the power comes to the front, x to the minus a half. The power decreases by 1. If you take away 1 from a half, you're going to get minus a half. So this is 2x. Now we have what? Minus 4. Bring back the x to the fifth down. If it's negative at the top, we bring it down to the bottom, it becomes positive. A half cancels 2, leave minus 1 over x to the positive a half. Alright? And so dy by dx would be equal to 2x minus 4 over x to the fifth minus 1 over the root of x. Example 17. In example 17, we're asked to find the gradient function of. Alright, so the first derivative, dy by dx, is the gradient function. Alright, it is a function that can be used to calculate the gradient of a curve for any value of x. Alright, that's what it is saying essentially. Alright, from here, y is the same as saying 4x squared over x cubed plus 3x over x cubed minus 2 over x cubed. All right. So here I can say that y is equal to 4 over x plus 3 over x squared minus, and we have what? 2 over x cubed. Bring the x's up, we have y is equal to 4x to the minus 1 plus 3x to the minus 2 minus 2x to the power 3. So now dy by dx, minus 1 times 4 is minus 4x to the minus 2. The power decreases by 1. Minus 2 times 3 is minus 6x to the minus 3. 3 times minus 2 is minus 6x. Ooh, what an error. Alright, but we spot it in time. This should have been a negative 3 here. So a negative times a negative is a positive 6x to the minus 4. So dy by dx would be equal to minus 4 over x squared minus 6 over x cubed plus 6 over x to the fourth power. Alright, here what we'll do is I would start up by expanding. So we have y is equal to, this is 24x squared, and come over here, I get what? Plus, sorry, that's not plus, that's minus. Minus 4x times 1 is minus 4x. 2 times 6x is 12x. And 2 times minus 1 is minus 2. Alright, so that's us binomial expansion. This is 24x squared plus 8x minus 2. So the first derivative dy by dx is equal to 2 times 24, or if you want, you could say 24 times the differential of x squared, which is 24 times 2x. So this is 2 times 24 is 48. X, the power decreases by 1, plus 8 times the derivative of x, which is 1. 8 times 1 is 1. And when you differentiate minus 2, which is a constant, you get 0. So dy by dx is equal to 48 plus 8.